For most of human history, survival meant understanding immediate cause and effect. You drop a rock, it falls. You strike a flint, it sparks. We see the world as a straight line of dominoes, where one action triggers an immediate, predictable reaction. That simple point A to point B logic built the modern world. We mapped our earliest industrial supply chains and financial models on this exact same premise, assuming that pushing a lever on one side of a factory would cleanly push a product out the other. But this relies on what engineers call a closed system, a theoretical environment completely isolated from outside interference. It assumes the weather, human behavior, and external markets simply sit still while your process runs. A straight line is comforting to look at on a spreadsheet, but the moment you drop that straight line into a hyper-connected modern environment, the illusion shatters. In 1958, agricultural planners in China instituted a highly structured campaign to increase crop yields by exterminating sparrows, which were seen as pests eating the grain. The directive was simple, linear, and ruthlessly executed. But within months of nearly wiping out the bird population, crop yields plummeted. Without sparrows to keep them in check, locust populations exploded and devoured the fields. The planners treated the ecosystem like a factory line. They failed to realize the sparrows were actually a critical regulator of the insect population. By removing them, the system reacted violently against the planners' original goal. That agricultural collapse was inevitable. Relying on linear logic to solve a complex problem creates a massive systemic blind spot, hiding the true shape of the environment you are trying to control. Nature doesn't operate on assembly lines. The underlying architecture of biological and mechanical networks alike is actually cyclical. This diagram shows a feedback loop. The output feeds directly back into the system. An amplifying loop accelerates this toward an extreme, like a screeching microphone. Alternatively, a balancing loop creates equilibrium, counteracting changes to hold the system steady. You cannot predict how a system will behave by looking at its isolated parts. You have to map these invisible, cyclical loops to see where the momentum is actually flowing. To see this in practice, let's test it against the global logistics network, a massive, interconnected web of ships, trains, and warehouses. Imagine a sudden, localized labor strike at a single shipping port in East Asia. A handful of container ships are temporarily stuck at anchor. Within days, regional trucking routes empty out. Local warehouses run dry because they operate on strict just-in-time inventory systems. By week 2, electronics factories in Europe are forced to halt their assembly lines. They cannot finish building their products without the specific microchips trapped on those delayed ships. That shortage hits store shelves next. The sudden scarcity causes the global consumer pricing index for electronics to spike sharply. Consumers react to those higher price tags by refusing to buy. The baseline demand for those specific laptops and phones drops out. And here is the loop closing. Because consumer demand has dropped, logistics companies cancel future cargo voyages entirely, permanently altering the maritime routes that triggered the event in the first place. The trickiest part of this cycle is the lag. The final systemic feedback, the drop in consumer demand, doesn't hit the shipping network until months after the initial port strike. By the time the dust settles, trade volumes, shipping rates, and manufacturing schedules have all adjusted to a completely different baseline. A single, isolated delay fed back into the chain again and again, mutating into a massive structural redesign of the entire network. This cyclical architecture extends far beyond cargo ships and economics. It governs human discourse, too. When you present a new idea, the communication is never a clean, straight transmission from the speaker directly into the listener's brain. The moment the words land, the thesis fractures. It is processed, filtered, and reinterpreted through the wildly different experiences and biases of every single person listening. If the audience simply listens and nods, the idea hits a dead end. But an engaged audience bounces interpretations back, turning a static lecture into an evolving conversation. An idea reaches its full potential only when it is actively challenged, pulled apart, and expanded upon by the minds encountering it. We've mapped out the mechanics of cyclical systems here, but right now, this video is just an isolated input. The ultimate implication of these concepts is sitting unresolved. You are the external variable. By challenging points in the comments, sharing them to spark new debates, and subscribing to join the analysis, You introduce necessary friction. That trailing blue node isn't going to close itself. Your engagement completes the intellectual circuit. Welcome to the feedback loop.